been waiting on this moment. You probably felt it. Take some notes. Got a lot to do today.
Dreams about it.
And I am missing Brittany and Rachel. Teresa's on the tree. Yeah, I think I marked all the retreats. All right, here we go. You remember back in chapter 4, you had to solve some triangles. Does anybody remember what we mean when we say solve a triangle? Find whatever's missing. That's exactly right. The difference is, back in chapter 4, your triangles were all right triangles. Now they are not going to be right triangles. Now, what does that mean to you? What does that mean if we don't have a right triangle? What can we not do?
The Pythagorean theorem.
Can't do the Pythagorean theorem. That's out. What else can we not do?
Sine, cosine.
Yeah, not going to have any of that 30, 60, 90 stuff going on.
You can't use sine, cosine, and tangent.
Well, we can use sine, cosine, and tangent,
Ooh,
but not in the SOHCAHTOA definitions.
no.
Because if you're doing SOHCAHTOA, what's SOH stand for? Sine is opposite over hypotenuse. And if you're involving a hypotenuse, then you have a right triangle. So, SOHCAHTOA, gone. Pythagorean theorem, gone. Special right triangles, gone. Now we're looking at just regular old generic triangles, and we are going to have to figure this out. Now, I'm going to do a quick demonstration. I don't want you writing this down. I just want you paying attention so that you can see where this came from. You remember from back in chapter 4, when we label our triangles, we use capital letters for the angles and small letters for the sides, right? And the sides are labeled across from their angles. Okay? Don't worry about this. No one's ever going to quiz you over it. I just want you to see where it came from. I'm going to drop an altitude in this triangle. I'll call it H. Everybody remembers what an altitude is? A perpendicular dropped from a vertex to the opposite side. Now, do I have a right triangle here? So would it be okay for me to say sine A equals H over B? Is that a legitimate thing for me to say in this right triangle?
Yeah.
All right, how about on this side? Can I say sine B equals H over A? Is that a legitimate thing for me to say? Now I'm going to take both of these equations, which came from these two little right triangles, and I'm going to solve them for H. So in the top one, H would equal B sine A. Everybody okay with that? And H in the bottom one would equal A sine B. Now, if both of these equations are equal to H, is it okay if I say B sine A equals A sine B?
Yes.
Sure, they're both equal to H, transitive property, right? I can set them equal to each other. Now I'm going to divide both sides by AB. You'll see why in a minute. What am I going to have left over here? What's this fraction going to be?
Sine A over B, or over A.
Sine A over A equals,
Sine B over B.
there is your law of sines. Now, I chose to drop this altitude. If I would have dropped this one, I would have come up with a very similar proportion, but it would have used different letters, maybe A and C, or B and C. The law of sines says in any triangle, right or otherwise, any triangle, the ratio of the sine to the opposite side is the same. So you can always set up that proportion to help you solve any triangle. So how would it work in our problem? Now you need to start writing this down, because now we're going to do this problem. We're going to solve this triangle right here. So how do you think this might look if we're going to use our law of sines?
Draw an end.
Oh, I don't need to do that anymore. I'm just going to go straight to here. I'm not going to mess around with any more altitudes. I absolutely could, but I'm too lazy. I don't want to do that. Could I set this up for this? What might this say? Sine 63 over what? Over 12 equals sine 58 over, well, a, x, whatever you want to call it. The sine of 53, or excuse me, 63, the sine of 63 over 12 equals sine 58 over a. Are you okay with that? Now, let's solve this thing. What shall we do to solve this? So, exactly, cross multiply, somebody said it. So, a sine 63 equals 12 sine 58. So, what is a going to equal?
Just gotta divide the 6 sine 63 over.
So, 12 sine 58 divided by sine 63. Let's go to our calculator. Let's type it in. Do remember, I know you guys already know this, but do remember, as soon as you hit sine 63, or excuse me, 58, as soon as you hit sine 58, you gotta close that parentheses before you do divided by. Let's see if we can come up with the right answer. I doubt your calculators in radians, so double check that too, always, always, always. What did you come up with for side A? 11.42. Everybody getting that? Okay, by the way, if we do not have a calculator with us, we will be dead in the water. So we need to make sure we have a calculator. All right, now we're not done. Remember, we're solving the triangle. So what would you suggest we do next? Well, we gotta find side B, but before we can find side B, maybe we better find
Angle B.
angle B. And angle B will be easy to find because why?
All the degrees equal up to 180.
Yeah, we know the angles of a triangle add up to 180. So being an incredibly lazy person that I am, I'm gonna take this into my calculator.
It's 59.
59. Now, set it up for me, angle, or side B. Tell me what proportion am I gonna set up to find side B?
Sine 63 over 12 equals sine 59 over b.
Beautiful. And I love the fact that you use 63 and 12. Sometimes kids will say sine 58 over 11.42. That is not the best way to go. Can you tell me why? Why is it better to use 63 and 12? Exactly. Why would we use rounded off information if we don't have to? Sometimes we may have to, but not this time. All right, so here we go. Let's solve. Let's see what you come up with for side B. Write as much down as you need to. At this point, you don't need to show any work, but if you need to write it out, that's awesome. Go ahead. Show as much work as you need to. .54 is what I got also. Anybody want to argue about that or have a question about that? Yeah, Jamie? Okay, what did you type in? here's what I wanna do. I wanna throw another one up here, and I want you to solve it and compare answers with your partner, okay? I'll do it too, but I want you to do it and make sure you can before we move on to the next step. So let's say, we got a 48 and a 62 and a 10. I want you to solve that triangle. So you're gonna find side H, side C, and angle S. Okay, so we should see pencils moving on some paper.
Would you do cosine 62 over 10?
Oh, whoa,
Oh,
we're using the
always
law of
Cosine?
signs, law of signs. Man, tomorrow will be the law of cosines.
Oh.
It will look different, but today we're doing the law of sines. I will write it down up here so we all remember. This one's a little bit different. How are you starting? What's the first thing you did? First thing you did was find angle S. What did it turn out to be? All right, because you need this fraction, right? This ratio. So you're gonna start with sine 70 over 10. And then you're gonna go from there. You done already? I'm just rounding to the nearest hundred. Nick, do I match you? Do I match you?
Yeah.
Got it. You say that now.
Are there any questions? Is everybody getting 9.4 and 7.9? You're sitting there thinking, oh my gosh, this is so easy, and you are right. But there is a snag. There is a snag, so we're gonna talk about that now. Notice, in the given information for this triangle, I gave you, what you had given was this, and this, and this. That was the given, right? You found everything else? In our last example, and I can't remember, I gave you this, and this, and this. Is that what I gave you? Okay. Now, both of those scenarios are awesome. think back to geometry. This information that I gave you was angle, side, angle. Remember that from geometry? And you know when you did your proofs, you were allowed to use ASA, angle, side, angle. That was one of your congruence postulates. Here, I gave you angle, angle, side. That was another congruence postulate you were allowed to use. Remember those things?
Yeah.
Okay. Well, there was one you weren't allowed to use. And the reason that you weren't allowed to use it, I mean, we always joked in geometry classes because it made a bad word. Remember that ASS, you weren't allowed to use it. But the reality is you weren't allowed to use it because that information does not necessarily describe a unique triangle. It could, but it doesn't have to. So we're going to look at a situation using angle, side, side information and talk about how you're going to deal with it. So here we go. It's still law of sines. You'll see why. Do you see the angle, side, side? Okay, now, if you're like me, you're going to get caught up in doing all the problems, and you're probably not even going to notice that. You're just going to say sine 58 over 10 equals sine C over 12. Does that make sense to you? So that's just what I would do. I would just write that down. However, at that point, my antenna need to go up. Because whenever we use the law of sines to find an angle, it's potential problem. Notice, in all my other examples, what was I using the law of sines to find? A side. No problem. No problem. But if you're using the law of sines to find an angle, boop, boop, antenna go up. Because it is possible that we're going to have an issue. Not necessarily, but maybe. So let's just go ahead and work it out and see what happens. I'm just going to multiply over here. So 12 sine 58 over 10 equals sine C. Would everybody agree with that? Okay, so I'm going to type this fraction in. Okay, and you get some decimal thing, right? Now, that is not angle C. How do we get from what's on the calculator, this fraction, a decimal, how do we get to angle C? What do we have to do? Yeah, second sign. Yep, inverse sign. So second sign, second answer. Uh-oh. What happened? It says error. This describes no triangles. That is an impossible situation. That triangle does not exist. You don't even have to worry about it because the calculator did all the work and told you error. Now, since you're just beginning, I might type it in again just to make sure I didn't type it in wrong. But if it comes up error, it means no triangle exists. Okay, that wasn't so bad. Let's try another one. Here we go. Again, we're just tooling along doing our practice problems and you run into this one, and so we're going to say, oh, okay, I'm going to set up my law of sines. Sine 72 over 18 equals what?
Sine C over 12.
Be B over 12.
Oh, B over 12, yeah.
And then, whoop, there went the chimney. Antenna have to go up because we're using the law of sines to find an angle. So let's see what happens this time. Okay, did you get a decimal here for this thing? And then what do you do after you get that decimal? That is not the answer. Remember, that's the sign of the answer. So what do we need to do? Second sign that answer. Uh-oh, I got an answer this time, did you? So angle B is 39.35 degrees. And here's where the exciting part happens, all right? If you get an answer, you must immediately check to see if there's a second answer. Okay? Now, I didn't do that here because there wasn't an answer. So I moved on. But if I get an answer, I immediately redraw my picture and say, okay, is there another possible answer for angle B? If there is, I'll write this down for you. The other possible answer, if it exists, this is an if, the other possible answer is 180 minus the first answer. In other words, it's the supplement. So my first answer was 39.35. So if there's another one, it would be 140.65. If there is a second answer, it is the supplement of the first one. So now I take a look at this.
It's not true.
It's not possible, is it? Why not? It's adding up to more. So this one doesn't work. The second answer doesn't work. So this triangle is the only possible solution. In your homework tonight, there's a set of problems that say how many triangles are possible. For this problem, it would be 0. For this one, it would be 1, because the second one didn't work. Sometimes it works, sometimes it doesn't. If, for example, you had done 180 minus and this had come out to be 100, then you would be okay. But it didn't, it came out to be 140, and that's just not possible. Jamie?
Will there be more than 2?
No, great question. There's either none, which is what happened here, or there's 1 or there's 2, okay? Let's do a quick example of having 2 solutions, and then I'll let you practice one on your own. So again, I do not want to make a big deal out of this. I don't want this to be something that you worry and fret about. I want you to look at this problem and say, ooh, law of sines. I want you to set it up. And then I want you to say, uh-oh, could be problems. I'm looking for an angle. Gotta check. Kind of flew through that. Is everybody okay with that setup? Everybody good with getting to this point? All right, let's see what happens. Did you get an angle? What'd you get? 85.72. So I immediately over to the side, redraw, and say, okay, is there a second answer? Well, if there is, it's real easy to check. Just take 180 minus that one. I got 94.28. Could I have a triangle with a 67 and a 94?
Yes.
Yes. So this situation has two solutions.
How do you find the second?
This one,
Yeah.
it's always 180 minus the first one. So when you second signed, Victoria, you got 85?
Yeah.
So it's 180 minus that. Yep, it's the supplement. And the reason that it's the supplement goes back to something, again, you learned a long time ago. If I said, what's the sine of 30 degrees, you would say 1/2. But if I said, what's the sine of 150 degrees, you would also say 1/2. There are two angles, supplements of each other, that have the same sine value. So when we solve for this, there are two possibilities. One in quadrant 1, one in quadrant 2. And I have to consider both of them. Not that they both always work, but I have to think about it. Okay, you ready to try one on your own? Okay, I'm not asking you to solve it all the way out. I just want you to tell me how many triangles are possible. So let's see how you do with this one. See if you can figure out how many triangles are possible. You see this and you think law of signs. You've got that pair that's set. So you're thinking law of signs. What'd you come up with here? 9. Yep, we don't have any triangles. All right, one more. Try this one. How many triangles are possible? Anybody wanna offer an idea? Trevor?
I got 2.
He got 2. Thumbs up on the 2, everybody good with 2? What was the angle A?
70.54.
75. And so the other angle A would have been about 105. And it's possible to have a 105 and a 59. So you think you got that under control? All right, let's look in your book if you have it with you. Hopefully you do. Page 485. 485. Number 44. Let's face it, in the real world, you are never, I promise, going to be walking down the street and find a triangle on the sidewalk that says, "Save me." That isn't what happens. These situations come out of real life problems. So let's take a look on page 485 at number 44. You need to be able to read the problem, draw a picture, and then figure out how you are going to solve it. So here we go. Try to find someone who has a book, or take a picture of it so you can read along with us, please. All right, number 44. Here's the tree. It would be so helpful if everybody could read along with us, so take a picture, please. All right, here's the tree. Here's observer A, and here's observer B. Everybody with me? Now what are these people doing?
Looking up.
They're looking up at the top of the tree. So here, he's looking up at the top of the tree. He's looking up at the top of the tree. Where do I put the 15 and the 20?
Is that the angle?
This is the angle of elevation, exactly. Remember, angles of elevation are always measured from the horizontal. So here's this guy's eyeball looking up at the top of the tree. That is his angle of elevation. What's the question? Find the height of the tree. Is there anything else I know that I do not have marked in this picture?
They're 400 feet apart.
This is 400 feet.
Do you know if they're like equally?
Actually, I know they aren't because the angles are different. If they were equal, they'd be the same, right? Because it'd be an isosceles triangle, but they're not.
Isn't, so the distance, like the 400 wouldn't be 200 and 200?
No. The only way it would be 200 and 200 is if they had the same angle. Since this is 15 and this is 20, think about the movie theater. If you have a 15-degree angle and a 20-degree angle, who's closer to the tree? Isn't he looking up higher? Not that that matters in this problem, but that's what's happening. Would it help if I took this out for a minute? Can you tell me anything about that triangle now? What can you tell me about it? What is it? 145, is that right? Is that arithmetic right?
Mm-hmm.
Okay.
So could you do sine 145 and 400?
Oh, sine 145 over 400 would equal what?
You just do sine 15. Oh, no, no.
Sine 15
Over X.
over,
Or, yeah.
I'll call it A to use my correct letters, A.
Mm-hmm.
Well, let's go ahead. I like where this is going. Good thought. Let's see if we can figure this out. By the way, Notice my antenna are not up. Because when do my antenna go up?
When it's on top.
When I'm finding an angle, and I'm not. So I'm not worried about anything. I'm just typing away, and I got 180.49. I don't know, I was talking and typing. Did I do that right?
And then should you do the same for 20? Or no?
Well,
You don't have to.
could we? Absolutely could we. But let's go back to what the question was.
Oh, equals 2. Sine 20.
This is the question, right? Now, that is a right triangle.
You do the Pythagorean, the 2.
Well, I
No,
can't
you would-
really do the Pythagorean
you do
theorem
sine 20
because I don't
equals
know
x
what
over
this
180.
is. However, could I say
Sine 20 equals x over 180.
that's what we're going to do? Sine 20 equals x over
So
180.49
make it fixed.
because that's a right triangle. In the beginning, I didn't have enough information to use that, but by backing up and doing my law of sines on the big triangle, I found that. And now I can set up my SOHCAHTOA. So, I got 61.73. Did you? And that would be feet or whatever our unit is. Are we good? Okay, I'm gonna let you go ahead and get started then, but here's the deal. If it says solve the triangle, find everything. If it says how many triangles are possible, 0, 1, or 2, that's all you have to do. Okay? So I'll give you your homework. It's actually in school with you, but I'll go ahead and write it down for you. Since you're here.
Right.
So I want you to go ahead right now and get started if you would.
Is this still on page 484?
Yeah. Yep. 5.5, that's section 5.5. Thank you, Amy. Okay, let's get started. You get a bunch of this done. Yeah.
I was in here yesterday, to take a test, I just wanna listen to the same person.
Okay.
So,
Can she come in tomorrow morning and take the test? I'll give it to her. Hopefully you- Huh? Did we-
no, I got her name written on one.
Oh, okay.
Where are we going? What? Wait.
What?
One of these tests can be handed back to us, we'll see what we got wrong.
I don't know. Why don't you get busy on today's lesson and get that under control? That is a great point. All my points are great, Trevor.
Yes, ma'am. That was the first time I knew what I was doing to that D. Like, no matter how good you get,
Trevor.
it's a 72%. You can't do it.
That was some dead time.